This is a new topic in our mechanical properties of fluids, surface tension. Suppose if you take a glass of water, if you leave it for some time, the upper surface will become thick. Or in case of a curd, suppose if you take some curd, the upper surface of the curd will become thicker than the internal or inner surface. You can take any liquid, the upper surface always acts as a stretched elastic membrane. So, the behavior of upper surface of a liquid which behaves as a stretched elastic membrane which possesses more energy than the molecules which are present just below this one is called surface tension. So to study about this surface tension, we need to discuss about molecular theory of the liquids. So what is this molecular theory? Now let me consider one beaker where we have taken some liquid. Generally we take water as the liquid here. So in this liquid, let me take 3 different points here at 3 different positions. So this is the first molecule, molecule A. This is second molecule, molecule B. This is third molecule, molecule C. Here, for every molecule, I am showing a sphere here. This is the molecule. Molecule A, this is molecule B, this is molecule C. You can see these molecules are surrounded by some other molecules nearer to this one. It is found that there exists a force of attraction between this molecule A and the nearer molecule if the distance of separation is only up to 10⁻⁹ meters. This we call it as 1 nanometer. So this molecule cannot attract a molecule which is here, which is present here. This molecule cannot attract this molecule. This molecule cannot attract this molecule. This molecule cannot attract this molecule. This molecule can attract only the molecules which are in this in a particular range only, in all directions. That means if it is the molecule, this side 10⁻⁹, 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 this side 10⁻⁹. So these are all the molecules in all sides. So you will get a big sphere here. That sphere radius will be 10⁻⁹, and this sphere is called, we call this sphere as a sphere of influence. Why? Because the influence of this molecule can be felt by other molecules which are in this range only, within this range only. So this is the sphere of molecule. Now let me take this molecule B, which is present nearer to the surface but not on the surface. Here also it can attract with the molecules which are in this range. And here these are the air molecules. So in this white region, I am not drawing anything there. These are air molecules. What about for molecule C? Here also these are the molecules which can be attracted by this molecule. But there exists an attraction between this molecule C and air molecules also. But that force is different. So here we have 2 different forces. One is cohesive force. The second one is adhesive force. So what is this cohesive? Just like the term colleague. Here cohesive means the force of attraction between similar molecules. This is force of attraction between dissimilar molecule. So in this case, you can see These are the molecules which are attracting this one. This molecule A can attract this one in this direction, in this. So these are all the forces that can act on this one. Similarly, this one, if you draw this one, these are the directions of the forces. These are all cohesive forces, because force between similar molecules. If it is suppose if you take kerosene, so this is a kerosene molecule and it can attract all the neighboring kerosene molecules, and here it will be like this. But what about the attraction between this molecule and the air molecule? There exists a force of attraction between dissimilar molecules also, just like in this example, kerosene and air. So this attraction is known as adhesive force. This type of force is called adhesive force. But when it is found that causal force always dominates the adhesive force in most of the cases. Now here, the causal force is more, adhesive force is less. But you can see the kerosene molecules can attract with the container also. Container is not made of kerosene, it is made of some glass, some steel. There exists a force of attraction between these two, that is also adhesive force. Now, in this case, it is found that this is attracted by all the molecules in its neighborhood. So this force is always attractive force, as it is a cohesive force, this attractive force. So the net attractive force except this one should become 0. Why? Because it is surrounded by a similar molecules, net force will be 0. But this is, as it is attractive force, attractive force always produces a negative potential energy. This already we studied previously. So attractive force always produces a negative potential energy. But what about this one? Here, as the attractive force is less when compared to molecule A, molecule B is having less attractive force, means less negative potential energy. But what about the molecule C? Molecule C has exactly half of the potential energy possessed by this one. So let us say this is molecule A possessed 200 joules of potential energy, whereas molecule C will have only 100 joules of potential energy. Here potential energy is due to this attractive force. Here attractive force is more. Here attractive force is half of the attractive force possessed by this molecule A. That's why the potential energy is less when compared to this one. Actually speaking, it is not less. This is more than this. Why? Because this is negative potential, minus 200. This is minus 100. So potential energy is more. That means molecule C possesses more energy than the molecule A and B. When compared to this one, it minus 200, this is minus 100, this is minus 150 joules. When compared to this, this is more. When compared to this, this is more. So all the molecules which are present on the top surface have more energy than the molecules inside the liquid, inside the surface. So that extra energy possessed by a liquid, extra energy possessed by a liquid is known as surface energy. Now we know that the upper surface of a liquid will have some extra energy. That's why the energy possessed by that one is called the extra energy possessed by a liquid surface here, not liquid. Liquid surface is known as surface energy. So how to find the surface energy? Now let me take one liquid surface here, a thin film of a liquid that you can see the soap bubbles formed while washing the clothes. Here let us say this is a thin soap film, so liquid film. So these are the two guiders. This is a thin rod here. Length of this rod, let me take this length of this rod as L. We know that every surface, liquid surface will have some energy. This energy is, let us say, initial energy U. The energy of this liquid film which is shown in this diagram is U. Now, the energy per unit area, suppose if we take 1 unit area here, so I am taking this as a unit area. For unit area, the energy possessed, let me take it as S. So SC, this is the total energy of total surface energy. The total surface energy by total area of this one will give surface energy per unit area. This is surface energy per unit area. Here what I can write, let us say the total energy of this one is 100 joules and the area of this one is 20 meters square. So this is 100 joules by 20 meters square. So this is 5 joules per meter square. This is the surface energy per unit area. Generally we denote this with the letter S. Surface energy per unit area. Now, if I move this rod slowly towards right, slowly, that means I am going to increase this area. The surface will have some area. If you increase this area, energy of this film will increase. So initial energy was U. Now, if you increase the area by increasing the area, the total energy will increase to U dash. Now, so for this I need to do some work. To increase this soap film area, I need to do some work. Let us say this is the new position of the rod after some time. So this is let us say distance traveled is D. So what is the work done by me against the internal force? So actually this rod is kept here. This rod is kept here. There is a force of attraction between this and the liquid, that is adhesive force. So I am doing work against that adhesive force or internal force. So what is the work done against internal force? Work done against internal force, which is given by W is equal to force into displacement, where F is the force applied by me, which is exactly equal and opposite to the internal force between the liquid and within the liquid. So this is work done. Let me take it as 1. We know that from work energy theorem, work done should be equal to change in energy, whether it is a change in potential energy, change in kinetic energy. As I am moving this rod very slowly, here the change in kinetic energy almost negligible. Actually I am moving this one with some velocity, but I am moving it very slowly. If I apply a large force here, then the film may break. But I should not break the film here. So I am moving it very slowly so that the film will not break. That's why change in kinetic energy is almost 0 here. Now this work done should be equal to change in kinetic energy or change in potential energy. Here change in the surface energy. So in this case I am going to write work done in increasing the surface area of the film, in increasing the surface area of the film is equal to change in that extra energy we call it as surface energy. So change in surface energy of the film. So what is the work done? We know this formula, force into displacement equal to, what is the increase in surface energy? If you know the surface energy, increase in surface energy, we know energy per unit area is here. Here I have written S is the energy per unit area. Let us say area increased by this much. This is the increase in area by moving this rod on these two gliders. So this is the increase in area. How to find this increase in area? We know that this is L, this is D. So increase in area is this is d into L on this side and 2 into L on other side, because we need to take because film has two surfaces. So it is not increasing only this side, it is increasing on other side also. So this is 2 into dl. This is the increase in area. So what is the increase in total energy? Initially for this blue color region, total energy was U. Now by increasing the area, the new energy will be U dash. So what is the increase in surface energy? We know for unit area, surface energy is S. So what is the increase in surface energy? Increase in surface energy, which is given by surface energy for unit area. This is surface energy for unit area into the increase in area. This is 2 into dl. So this is equation 2. So I am going to write change in surface energy is S into 2 into dl. dd get cancelled. So from this S can be written as F by 2L. So this is surface energy per unit area. S is the surface energy per unit area is also equal to the force acting on that one per unit area on both sides of that wire. Why? Because this will have force on both sides. So S is equal to F by 2L or simply F by L. But what is the SI unit and dimension formula for this one? Force is measured in Newton, 2L or L is measured in meter. So Newton per meter is the SI unit for surface energy. And the dimension formula is given by ml t minus 2 by L. L get cancelled. M L power 0 t power minus 2. This is the dimension formula for surface energy. Surface energy per unit area. This surface energy for unit area is also called surface tension. So S is equal to force by length. So the definition is, the definition of surface tension, now I am going to write here one more definition. Force acting per unit length on an imaginary line drawn on the surface of a film. Now if you draw one imaginary line here, this will experience force on both sides, this side and this side. So the force experienced on this imaginary line per unit length is called surface tension of this liquid. So formula is force by length. Surface energy, if you take a liquid here, so if you take the molecules inside this one, if the molecules attract with each other, it is found that the surface energy is always reduced. If they repel with each other, then the surface energy will increase. Generally, almost all these molecules which are on the top surface are in this interior of this liquid. So these are the molecules which are present at different places, different positions. All these molecules will try to get stability. To get stability, it is found that a molecule or a system is said to be stable if its potential energy is least. So if the potential energy is least, then the system is said to be in stable equilibrium. Now we know that, so this is the ground, earth level. If a person stands here, he will be more stable. If the same person stands on a building, when compared to person A, person B is having more potential energy. His potential energy is mgh, where h is the height here. So here potential energy is more. As the potential energy is more, he is less stable. But here the potential energy is said to be 0. So he is said to be, when the potential energy is less, he is said to be more stable. Suppose if you are flying in sky in an aeroplane, as your height is too high, your potential energy is too high, you are said to be less stable there. But even though you are in equilibrium, you are said to be less stable. So the chances of falling from a tree is more. Why? Because you are on the branch of a tree here. So when you are standing here, your potential energy is more than this. So when the potential energy is more, you are less stable. So these are the examples. So very simple point. Very simple point is, whenever the potential energy is least, the stability will be more. Here, if you take this one, 1, 2, 3, 4, 5. Out of these 1, 2, 3, 4 and 5, the fifth molecule is having more potential energy. So as they have more potential energy, out of this 1, 2, 3, 4, 5 has more potential energy and 1 has least potential energy in this set. As it is having least potential energy, this is more stable. The molecule 5 is more stable. Molecule at the bottom of the container is always said to have more stability than the molecules on the upper surface. So that's why, to get this stability, all the molecules on the upper surface will try to come down. That means they will try to reduce the potential energy. By reducing their potential energy, they will get more stability. That's why the molecules on the upper surface will come closer to each other and they will try to move downwards. That's why surface energy always acts downwards here. This surface energy acts downwards for the molecules which are present on the upper surface. As the surface energy is acting downwards, here the molecules will be crowded together when compared to the molecules here. That's why the upper surface will have more thickness than the thick layers in the bottom surface or interior surfaces. This behavior is known as a surface tension. So due to this, it will act as an elastic membrane only. That means if you apply some force and if you remove that force, and once again they will regain their original shape as well as original size as well as original structure. That's why the behavior of this upper surface to act as a stretched elastic membrane is called surface energy, or also called surface tension. Now generally, if you see this one, these molecules are in contact with the other molecules which are present nearer to them. But sometimes if you take this one container and there may be two different liquids which are poured here. If they are immiscible, it may be immiscible or mixable liquids, whatever may be. Here I am showing immiscible liquid. There exists a force of attraction between these two. So as these two are different, this force is called adhesive force. If these molecules of these two liquids attract with each other, the surface tension always decreases. Suppose if these two repulse with each other, if it repulse, if it wants to move in this direction, if it wants to move in this direction, if these two repulse with each other, if the molecules of two different materials repulse with each other, surface tension always increases, or surface energy always increases. So whether it is a surface energy, surface tension, here surface energy as well as the surface tension, both are similar terms. Okay, so this is energy per unit area, this is a force per unit length. So both are same. Energy per unit area or force per unit length. Energy is nothing but force by area, force into displacement. This is area means length into displacement. So the dd cancel, we get once again force by length. So we can use both terms, surface energy or surface tension, for this to explain the same phenomena. So in this case, I am going to write the SI dimension formula for surface tension. Already we used this one. Instead of that, you can write energy per unit area. Energy per unit area is also another formula. Energy is measured in joules area meter square. This is also another SI unit for surface tension, surface energy. So this is also equal to force per unit length. And even if you want to write a dimension formula, ml square t minus 2 by area L square cancel, once again you will get the same dimension formula what we obtained earlier. Measuring the surface tension of a liquid. We know that if you take some liquid in a container, this is the container, and if you keep a solid here, this is liquid surface and this is a solid which is placed on this one. The solid surface will stick to the liquid, or liquid stick to the solid only if the surface tension of this solid and liquid less than the surface tension between solid and air plus the surface tension between liquid surface and air. Why? Because surface tension does not belongs to a substance, it belongs to two surfaces. Here S stands for solid, L stands for liquid. If the surface tension between solid and liquid is less than the sum of the surface tension between solid and air and liquid and air, between solid and air there is a surface tension, between liquid and air there is surface tension, sum of these two is more than the surface tension between solid and liquid. As we discussed earlier, whenever surface tension is less or reduced, surface tension between two surfaces is reduced if there exists a attractive force. Please remember this one. Here these two can attract or stick together if the surface tension is less than the surface tension between this and this. Here air is common between liquid and air and this one and air. If these two surface energies are more and the surface energy between this solid and liquid is less, then only the liquid stick to the solid. Liquid sticks to the solid surface. If these two have less surface energy, then these two will not stick. This you can see in case of suppose if you want to touch the mercury, you cannot touch mercury, it will not wet your hand because of this reason. The surface tension between your solid surface, that your finger, and the mercury is greater than the surface energy between the your finger and air, and the surface energy between that mercury and air. So please remember this one. I will clear it. Mercury will not stick to fingers as surface energy between mercury and fingers is greater than the surface tension between mercury and air and the surface tension between fingers and air. This is the concept. Similarly, if you see a duck when it is swimming in water, water will not stick to the duck. The same reason, this one. But water stick to our body. That means it all depends upon the surface tension between our body and the liquid which is in contact with us. Water can stick to our body very easily. Reason being, the surface tension between water and the human body is less than the surface tension between water and air, plus surface tension, sum of the surface tension between water and air and hand and air, or human body and air. Here H stands for human body. That's why water stick to us, because surface tension is less. Here, how to measure this surface tension? For this a small experiment. This is a small glass slab which is connected to a rod here with the help of a string, and the other one is one pan here. This is a pan, and this pan can be kept, this balance can be kept in equilibrium by adding some load here, because it has some load, pan has some load, so these two are in equilibrium now. Now take a container in which some liquid is placed. We are finding the surface tension of this liquid. Remember, these two are not in contact with each other. So this is the condition. Now you just move this, bring this container so that the liquid in contact with the lower surface of that glass slab. Due to this, this glass slab will stick to water or water will stick to the glass slab. Due to this, it will be pulled down. So this is glass slab will be pulled down due to the surface tension of this liquid. That's why we have to add some more weight here. The extra weight that is added here, let us say m grams. So what is the, when it is added slowly at a particular mass, particular load, this one, the glass slab will come out of the surface of the liquid. It slowly comes out. So a small gap will be found between these two. So by measuring this load, what is the load that is added extra? This is the load added extra load added, mg. So if the length of this rod, this glass slab is, let us say L, and this force will act on both surfaces, we can write the surface tension is equal to load added by the length on both sides of this glass slab. So this is also called weight by 2L. So by doing this simple experiment, you can find out the surface tension of this particular liquid which is given here. This one is the surface tension between the liquid and the air only. This is not the surface tension between the solid and this liquid. So the subscript is LA here. That is the surface tension between liquid and air surface. Why? Because whenever surface tension of a liquid is given, that is the surface tension between liquid and air, because air should be considered as one surface, and because this surface will divide this air and liquid here, that's why this is surface tension between liquid and air, which is equal to W by 2L. If it is not mentioned always, if the surface tension of liquid is given, always take it as it is the surface tension between liquid and air. It is found that if you heat this one, whenever temperature increases, it is found that surface tension of that liquid with respect to air always decreases. Whenever surface tension decreases, surface tension is reduced, attractive force will increase. That's why, especially while washing the clothes, if you wash the clothes with ordinary water means water at room temperature around 25 degrees to 35 degrees centigrade. At room temperature, the force of attraction between the dirt and water will be less. Force of attraction will be less due to high surface tension between water and this dirt. But if you heat it to 60 degrees or 70 degrees centigrade, then it will become hot water. Then surface tension of the hot water is always less. When the surface tension decreases, there is attractive force. Now water can attract more dirt. That's why it is easy to wash the clothes with hot water than the ordinary water. Reason being, here by increasing the temperature, we are decreasing the surface tension. Please remember this one, very very important for 1 mark. Whenever temperature increases, temperature of a liquid increases, its surface tension always decreases, mostly, not always, generally decreases.